is one of the first types of free response questions that you can expect to see on the exam. Accumulation type problems, they really like those, and they're typically calculator active questions. So let's dive into this one. Part A says find G prime of 5. Find G prime of 5. So we are, I would use my calculator on this. Okay, use your calculator to evaluate this. So when you're taking a derivative, and I know that the 89 is slightly different from this one, but you can go to your math menu. Here's your derivative function. You type it in. Cosine, make sure you are in radian mode. X squared over 18, comma, x. And when you want to evaluate it at a certain value, let me find if I can find it. I can't find it on this one, but on the 89, there's a line that looks like the absolute value bar. You can put a line there, and you would put x equals 5 in this case. So what I'm going to have to do is I'm just going to have to find the derivative. Whoops, it didn't like that. I'm not sure what it doesn't like. Maybe I need to put a 1 for the first derivative. No, it didn't like that either. Okay, never mind. I know that it works on the 89. So just kind of ignore that. Let's find the derivative here. We'll do it by hand. G prime of t, the derivative of 90 is 0. The derivative of cosine is negative sine, so that's negative 45 sine of t squared over 18 times, don't forget the derivative of the inside. The 1 over 18 is obviously a constant, times 2t. So that is our derivative. Then we would plug in 5. And I'm just going to let my calculator do this. I'm not going to worry about writing it out since I've written out the general function here. Negative 45 sine of 25 over 18 times, got to put in parentheses, 2 times 5 over 18. Okay, we get negative 24.587. Remember that we can always just write the first 3 decimals after the first 3 digits after the decimal sign, but you definitely have to have the first 3. You don't need to worry about rounding. I would just do what they call truncate every time. So that is G prime of 5, negative 24.587. You get 1 point for that. Okay, you get another point. It says using correct units, interpret your answer in the context of the problem. So let's look at what G shows us here. G, it says on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by this function. So G was already a rate, and we took its derivative, so we're talking about the rate of a rate. So we can say it this way: the rate at which gravel is arriving is decreasing. Okay, I'm using the word decreasing. I'm not going to include the negative with the number when I write it right here because I said decreasing. Okay, you want to write it in words, not, and I use 0.7, not 0.8. You want to write it in words. So if it was positive, then it would be increasing. Since it's negative, it's decreasing by 24.587 tons per hour per hour, because we were originally tons per hour, and then we're talking about a rate here, so that's tons per hour, or tons per hour squared is probably how you're used to it. You do need to be specific at time t equals 5 hours. Okay, so you get 1 point for the value, 1 point for your interpretation. Okay, let's look at B. It says find the total amount. Total amount, you should be thinking accumulation. Anytime you see accumulation, you should be thinking integral. Find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. So let's find out. Our hours of operation are 0 to 8. So I know that we can jump straight to the calculator and go ahead and type this in, but you should always set it up. So we need the integral from 0 to 8 of g of t. You do not need to take the time to write that out. You do not have to write the function there. Don't take the time. Don't worry about it. Just put the function notation, and then you're simply going to calculate it in your calculator. So let me scroll back up so I can see my g function. My calculator will do this on math. Integration. 90 plus 45 cosine x squared over 18, comma x, comma lower bound, comma upper bound. And it takes a second to give me 825.551. And you should always include units. Even if it doesn't say to include units, it never hurts to include units. So here you get 1 point for your integral, just writing that, even if you forget that your calculator will do it or whatever, you get 1 point for setting up your integral, 1 point for your answer. So you do have to have that integral there, even though it's pretty obvious that that's what you're having to do. Okay? Part C. Is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5 hours? Show the work that leads to your answer. Now, this one's a little tricky. This is usually where they get people, is here in part C. They ask a question that's a little kind of confusing. But let's think about this. We're trying to find out, is the amount of unprocessed gravel at the plant increasing or decreasing at time 5 hours? So let's see. It's arriving. G of t tells us the rate at which it's arriving. And then it says it processes it at a constant rate of 100 tons per hour. So really, what we need to do is we need to find G of 5, not G prime of 5. We need to find G of 5. So just plugging that into our function in our calculator gives us 98.140. So that's the rate at which it's being processed, or no, that it's arriving. Okay, that's the rate at which it's arriving. Arriving rate. It's being processed at 100 tons per hour. So its arriving rate is less than its processing rate. So therefore, the amount of unprocessed gravel is decreasing because we're not bringing in as much as we are processing, okay? So you do need to write that in words. So at time t equals 5, the rate at which unprocessed gravel is arriving is less than, you don't have to mention it, you already have it written down, is less than the rate at which it is being, avoid words like it, okay, be specific, is less than the rate at which unprocessed gravel is being processed. Well, let's just say the gravel is being processed. The rate at which the gravel is being processed. Therefore, the amount of unprocessed gravel is decreasing. Man, I can't spell decreasing. And I've already said the time, but can't hurt to say it again. At time t equals 5. Okay, so you get 1 point for your comparison up here, and you get 1 point for your conclusion. So that leaves us with 3 points for the last part, part D. So let's analyze part D. What is the maximum amount? Anytime you see maximum or minimum, you should always think, okay, you're usually thinking derivative, but I want you to be thinking critical points and endpoints. You have to consider the endpoints, and that's usually where they get you. You forget the endpoints. So what is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? So first of all, we haven't really come up with a function for the total amount. Let's go back to the original problem. It says at the beginning of the workday, we have 500 tons to start with. It's arriving at this rate, and it's being processed at this rate. So let's come up with an amount function here. Our amount at time t is equal to, we started with 500, and we're going to add the accumulation of our rates, right? From 0 to t of the rate at which it's being brought in minus the rate at which it's being processed, okay? So we have our initial amount, and I shouldn't use t's there because I use t in my limit. It's just a technicality there you need to be careful with. So let's use s, okay? So we've got our initial amount right here, plus our accumulation, our integral of the rate at which it's coming in minus the rate at which it's being processed. Okay, so that is our amount function. We are trying to maximize that, so we need to take the derivative. So the derivative of 500 is, of course, 0. The derivative of an integral is just the function with the limit plugged in. So that's g of t minus 100. We're trying to maximize that, so we need to set it equal to 0. Again, we would use our calculator to solve that for the time. Plug in your g of t function. You're either trying to find out where it equals 100 or where that minus 100 equals 0. I would not use the solve feature here. I would graph it. I would graph this right here and look for where it crosses the x-axis. And we only need to worry about between 0 and 8 because that's only where our function is applicable. So graph g of t minus 100, look between 0 and 8, find where it crosses the x-axis. You will find that at t equals 4.923. It only happens once. So we need to check our endpoints, 0, our critical point, 4.923, and our other endpoint of 8. And we are plugging this into our a of t function right up here. Okay, so if you want to put that in your calculator in some way, you need to figure it out. So obviously at time 0, the amount is 500. That kind of makes sense. That's how much we started with. When you plug in 4.923, oh, and also don't round right here, 4.92348. It's probably not going to make a huge difference, but when you find that number, if you could store that somehow in your calculator, store as x, so that you don't have to worry about rounding. In this scenario, it really doesn't make a big difference, but if you're dealing with the exponential function, it may make a really big difference. So we get 635.376 for our critical point, and we get 525.551 for the end of the day. So obviously there's our maximum amount, and you should always say it in words. the maximum amount of unprocessed gravel. You need to be specific, the maximum amount of what? Unprocessed gravel at the plant during the workday. You could list the specific times there if you wanted to. Is 635.376 tons. Always include those units. So you get 1 point for this part right here, considering the derivative equal to 0. You get 1 point for your answer and 1 point for your justification. So your table over here is your justification. This is fine for your justification as long as it is clearly labeled and clear as to what it is. You could also do A of 0 equals 500, A of 4.923. You could just list it, and then you get 1 point over here for that's your actual answer. Okay.